Alright guys, this section is solving linear systems by adding and subtracting. It's also called elimination. This is chapter 7, section 3. We're still in unit 8. Okay, the vocabulary for this section is the same as the two before. We're still dealing with system of linear equations, and we're trying to solve these by using different methods. Alright, so here are the steps to solving linear systems using the elimination method. I want you to pause the video and copy these down. I'm going to explain them more in detail as we work examples. Alright, so let's look at a few of examples of the elimination method. When you have your equations, you're either going to end up adding your equations or you're going to end up subtracting your equations. So the first step is to get them both in the same form. So I see these are both already in standard form. They have the x's line up, the y's line up, and the constant right here line up. So step 1 is already done for us. We can go to step 2. We're going to add or subtract. This one I already went ahead and put adding, but what you're going to do is you're going to go down and you're going to add each term. Okay, so when I add 2x and negative 2x, these cancel each other out. So this is pretty much the gist of the elimination method. A term, one of the variables is going to cancel out and give you 0, and then you'll do the rest of them. So 3y plus 5y is going to give me 8y, and then 11 plus 13 is going to give me 24. Okay, so when you have two terms that are one's positive and one's negative, and they both have the same coefficient in front, you're going to be adding them so they cancel out. So let's go ahead and solve this one, finish solving this. That was step 2, we added or subtract. Now we're on step 3, we're solving this. So we need to divide by 8. Get y equals 3. Okay, so we just solved it. Now we're on step 4, which is kind of like when we use substitution. Once we find an answer, we plug this back in to solve for our other variable. So we're going to substitute 3 back into one of these so we can solve for x. So let's plug it back into the top one. So we have 2x plus 3y. My y is 3. Equals 11. Alright, so now I'm going to solve this for x. So I have 2x plus 9 equals 11. Subtract 9 on both sides. 2x equals 2. Divide both sides by 2. X equals 1. So that was step 4. The last step is to check your answer. So our solution was, our x value was 1 and our y value was 3. So this is the same solution we would have got if we solved this by graphing or if we solved this by substitution. This is just another method of solving these using elimination. Okay, so let's look at one where you'll be subtracting. So in this second example here, we see that we have coefficients that are the same in front of the same variable. So we're going to be subtracting. So pretty much an easy way to think of this is you're going to change each one of these. So this one will change the negative, this one will change the negative, this one will change the positive. So if you go ahead and change each one, you're pretty much adding at this point. But if you didn't put these, you would just subtract. So 4x minus 5x would give me negative x. 3y minus 3y is going to give me 0. And 2 plus 2 is going to give me 4. Alright, negative x equals 4. This one, when we started, they're already in the same form, so step 1 was already done. We just added or subtracted. We were subtracting, so pretty much we changed the sign on each of these and then added. Okay, so now we're on step 3. We're trying to solve this still. So I'm going to divide by -1. I get x equals -4. Alright, now we're on the substitute step. We want to find out what y equals, so we're going to substitute this back in for x. I'm going to go ahead and use this top equation. So I have 4x, which my x is -4, plus 3y equals 2. Okay, when I multiply these together, I get -16 plus 3y equals 2. I'm going to add 16 to both sides. You get left with 3y equals 18. The last step here is divide by 3. You get y equals 6. So our solution for this one was x was -4 and y was equal to 6. Alright, so these are the two different cases you're going to run into. Either they're already, one's positive, one's negative, with the same coefficient, and you just add them straight down. If they're the same, then what you'll be doing is subtracting. So if you would want, you can go ahead and change one, and then just go ahead and add going down. Okay, let's try to get through 2 more examples real quick. Alright, on this one, the equations we start with, we see they're not in the same form. So we want to put them in the same form first. I see this top one's already in standard form, so I'm going to go ahead and try to put this bottom one in standard form. I'm going to start by moving x to the other side, because I want to have x and y on the same side. So I'm going to subtract 3x from both sides. What I'm going to get -3x, and then I have a positive 4y equals, this term got canceled out, and I'm left with a positive 14. Okay, now if I want to do my elimination, I'm going to go ahead and write this other equation under it, so we have them both lined up. I have 8x minus 4y equals -4. Okay, so now looking at these two equations, they're both in the same form, so I'm done with step 1. Now I want to add or subtract. Since these are already opposites, I can just go ahead and add these going down, because this term will get canceled out and give me 0 if I add 4y and -4y. So now if I add -3x and 8x, I'm going to get 5x. And like I said, this is going to give me 0 for the y terms. And now -14 plus 4 is going to give me 10. Alright, so what I'm left with is 5x equals 10. So next step here is to divide by 2. And I get x equals 2. Alright, once I just did I added and subtracted here. Then once I got to this, I went ahead and solved for x. Next step is to substitute back in, which we've done before when doing substitution, where we find one answer and then substitute that back in to find the other one. So for example, I can substitute it into any equation. I'm going to go ahead and substitute it into this top one. So I have 8x, which my x is equal to 2. and then minus 4y equals negative 4. Okay, so 8 times 2 is going to give me 16. Subtract 16 from both sides. It's going to cancel. I'm going to have negative 4y equals negative 20. Divide by negative 4. We get ry equals positive, because of the double negative, 5. Alright, so we got our y, we got our x, we can write our solution. And step 5 is to check this answer by plugging it back in. So we'd plug in 2 for x, 5 for y in both equations and make sure that they both check out, which we can do that, and they would. Okay, so let's try the other equation here. First, we want to put them in the same form. We see the top one is in standard form, this bottom one isn't. So I'm going to go ahead and add 2y to both sides so I can get x and y on this side. I'm going to add 2y, both sides. Okay, if I rewrite this now, this is going to cancel out. I'm going to have 2y plus 7x equals 3. Okay, but when I look at my equation up here, the 7x is in front, then comes a 2y, so I need to switch these. So these two right here, I'm just going to switch them. I mean, they're still both being added to each other and they're both positive, so I'm not really changing the equation, the value of it. I still have positive 7x plus 2y, and this is equal to 3. Okay, so this was the second equation that I just rewrote. I'm going to go ahead and rewrite this other one, this first one under it, so we can go ahead and try to add and subtract. So I have 7x plus 2y equals 3. Alright, so if you notice something here, we ended up getting the same equation. So what do you guys think will happen when we try to do elimination here? Everything's actually going to cancel out. We see we have the same coefficient, so we would want to change this one to subtract. So if I subtract, I'm really changing everything to the opposite, so from positive to negative or to negative to positive. So since everything here is positive, everything's going to switch to negative. So now 7x minus 7x is going to give me 0. 2y minus 2y is going to give me 0. And 3 minus 3 is going to give me 0. Okay. This means that if we get 0 equals 0, this means that our lines coincide and they're right on top of each other. So for example, when we did substitution, and we would get like 4 equals 4 or 7 equals 7. We knew that they coincide. For elimination, you'll get 0 equals 0. If they're parallel, you'll get that 0. They're parallel. You'll get 0 on the left, and you'll get that it's equal to some number. Like for example, 3. So this is not true, so this is parallel if you do elimination. If they coincide, you'll get 0 equals 0. So this is many solutions, or you could put any real number. Alright, that's it.